United States will launch the Phoenix Mars lander. I imagine you're following that, huh?
Oh yeah, we're very excited about that. Early August, that's right. We're hoping to watch at least slightly delayed playback of the launch if we can. We do use a 20-minute delay for our communication, so that's why we'd have to wait a little bit usually. But yeah, absolutely. And several of us on the crew are also Canadian, so we're looking forward to we're friends with some of the Canadian collaborators on that project as well. Right. Very exciting.
Does this make you even more eager to see humans on the red planet?
Absolutely.
Absolutely. I'll second that. Yeah.
How do you think a human explorer? I mean, there's been all these robots, and no one's going to Mars yet. A lot of work's been done with landers and robotics. But how do you think a human explorer, based on the experience you have and that you've had in this simulation so far, how can a human explorer make a difference?
Well, speaking as a geologist, nothing beats a trained scientist in terms of finding what you're looking for in the field. One example that I actually wrote about in one of my journalist reports a few weeks ago is looking out the windows here. It's a barren landscape. It looks like a dead landscape. All you see are scattered rocks, sharp rocks that have been thrown around by the meteorite impact, and that's all. There does not appear to be any life anywhere whatsoever. But as soon as you get outside, and as soon as you look at the ground and just start to look a little bit more closely, you'll see fossils, and you'll see some lichens and mosses growing on some of the rocks, and you'll see water flowing beneath some of the rocks. And there's life everywhere once you get your nose right down to the ground and take a look. And it's highly possible that a lot of the rovers might pass over some of these things because they're just not programmed perfectly, perhaps, to look for things that you can't program for. I mean, a lot of science, after training for years and years, becomes almost intuitive. So there's that, and also just some of the locations that you need to get to. I'm also a rock climber, so I can appreciate the difficulty that it takes to get to some of our most interesting sites. And I think there are some things you just can't train robots to do. So I think a good combination of human and robotic exploration is what we're going to need.
And just to add to that, I mean, youth or young children or just a person on Earth here seeing out of the eyes of an actual astronaut being on the surface of the moon or Mars, I think really sparks enthusiasm, as is as well. I mean, students can relate much more easily to knowing that an astronaut's on the surface of another world rather than a robot. So I think that's just another thing. I mean, I think it's in the nature of us as humans to go out and explore. So, you know, that's definitely the next step. We have some robots, as you know, exploring Mars, and more are going to be sent. And, you know, there are plans now to put people back on the moon no later than 2020, and hopefully that continues out and gets us to Mars as well.
And what do you hope your roles will be in the future? You're both working on advanced educational degrees, graduate degrees. What do you hope to do in your future? I mean, this is an extremely interesting project you're working on now, for lack of a better word here.
Oh, we want to go.
What your future brings?
Yeah, I think we both definitely want to go, as Melissa said, and you know, we are definitely excited about how things are turning around, sort of, in the, you know, international global exploration push here, and the real push to send humans back to the moon and Mars. And I think, you know, timing wise, it could work out pretty well for us, at least for the moon, hopefully.
Yeah, I sure hope so. And I mean, failing that, just being involved with this is exciting in itself. And, you know, I'd be almost as happy to get to train the people who do get to go to the surfaces of other planets and keep on working on that data from here in addition as well. I mean, it's all very exciting, whatever we can get. Hopefully setting our feet on Mars.
It's been an amazing experience for you.
Absolutely.
All of us here, I think all 7 of us here are, you know, really thrilled to be up here working, and you know, just all of us share similar sort of goals down the road, so it's nice for us to be up here together.
Well, thank you very much. That's really the end of my initial questions, unless you have anything else that you like to add that we didn't talk about. The only other question I have here is that, Melissa, in your weblog, you said it's been both easier and more difficult than you expected. Were you talking about the sleep patterns and mealtime there?
In terms of the Mars time, yeah, the sleep patterns are great. I mean, some nights I'll be up late working and think, oh no, I have to get up in 8 hours. Oh wait, no, I have an extra 39 minutes to sleep. So that makes it a bit easier. But, well, one thing that's a little bit tricky with the Mars time too is the fact that now we're not only separated from our friends and family by distance, but also by time. Right. So some of us have been, really enjoying talking to our loved ones at home, and having them on the same time zone as us, or a nearby time zone anyway, makes it easy to be able to talk to them whenever we want. But as we are drifting further and further away from Earth time, it makes it a little bit harder to stay in sync with those people at home. So that was just a little challenge that I forgot to anticipate. It's not so bad.
Now, the way in which you're able to link is via computer, and how are those computers? Right. I mean, how is that power connected? I mean, what power do you use so that you can connect your computers? Is it the generator power?
Yeah, we're using a generator here in the Arctic. I mean, eventually when we do go to the moon or Mars, we're not going to be taking a diesel generator as we use here, but it provides just what we need here. I mean, the output is still power, and that's what we use to power our computers and our communication system that we communicate with people back home with.